Hello everyone. Previous lecture we have studied the concept related with the chapter conic section, and in that we define the parabola. We define the standard equation of the parabola. Here we consider two standard forms of the parabola. Let's revise these four forms, and we have to remember the points about the parabola. Here we have four standard parabolas. Here first is y square is equal to 4ax. Second is y square is equal to minus 4ax. Third is x square is equal to 4by. And last is x square is equal to minus 4by. We see the various equations, or we define these equations in last lecture. Okay, so here points to remember about the parabola are your vertex. Where is our vertex? Then the focus, the fixed point. Okay, then next is equation of directrix. Equation of the directrix, that is the fixed line. And next, endpoints of the lattice rectum. We know lattice rectum is a chord which is perpendicular to the axis, and here we define the end points of the lattice rectum. Next, here length of lattice rectum for each parabola. In each parabola, then axis of symmetry. The parabola is symmetric to the given axis, and in last, here equation of the axis. Equation of the axis, that is axis of symmetry. Herefore, the y square is equal to 4ax. Since we consider the standard forms of the parabola, here in each vertex is same. Then here for focus, here for the parabola y square is equal to 4ax, here focus is always on point A0. If focus is on point A0, your equation of the directrix is x is equal to minus a, that is x plus a is equal to 0. Next, here endpoints of the lattice rectum. We know here we consider the chord which is perpendicular to the axis, and we define the endpoints as L and L dash in last lecture. Here for L, coordinates are A to A, and here for L dash it is A minus 2A. So remember these points. Here the length of lattice rectum. Here for the parabola y square is equal to 4ax and y square is equal to minus 4ax. Here length is 4a and 4a are same. Next, here axis of symmetry. Here we consider the symmetry for both the parabolas. Y square is equal to 4ax and y square is equal to minus 4ax. Here is on x-axis. And we know equation of x-axis is always y is equal to 0. So remember all these points. In next, we define the parabola x square is equal to 4by and x square is equal to minus 4by. Here axis of symmetry, here is y, and we know equation of y-axis is always here x is equal to 0. Since we consider the standard parabola, here vertex is at origin, then here focus, that is the fixed point, here is 0b, is the point whose coordinates are 0b for the first parabola and 0 minus b for the x square is equal to minus 4by. Next, here equation of directrix is, here for the x square is equal to 4by, we consider y is equal to minus b, that is y plus b is equal to 0. And for the x square is equal to minus 4by, it is y is equal to b, that is y minus b is equal to 0. So these are the equation of directrix. Then again we define the endpoints, that is L and L dash. Here L for the x square is equal to 4by, that is endpoints. Here are 2b and minus 2bb for x square is equal to 4by, and here 2b minus b and minus 2bb are for x square is equal to minus 4by. Okay, so here the length of the lattice rectum, since L and L dash are our endpoints, here length, that is distance in between L and L dash, here is 4b for both. For both it is 4b. So remember all these points, we define all these points in last lecture already. Okay, so in today's lecture we have to see some important examples related with these formulae or related with these parabola. Let's go with our example. Here first example is find the coordinates of focus equation of directrix length of lattice rectum and coordinates of endpoints of lattice rectum of the parabola. Okay, so we have to find all those points. Here coordinates of the focus, then the equation of directrix, next length of the lattice rectum, then coordinates of endpoints of the lattice rectum to the parabola. Here in the first given 5y square is equal to 24x. This is the equation of the parabola. Okay, so we consider this equation again. Consider here 5y square is equal to 24x. Let's divide both the sides by 5. If we divide, here we get y square is equal to 24 upon 5x. 24 upon 5x. Now here everyone knows this y square is equal to 24 by 5x is of the form y square is equal to 4ax. Remember our first standard form of the parabola, here is y square is equal to 4ax, and this equation is of the form here y square is equal to 4ax. Let's compare this equation with our standard parabola. Then here we get 4a is equal to 24 by 5. Okay, then we find here a separately. So here a is equal to 24 by 4 into 5. This is equal to, here we get 6 upon 5. So here we get a, and here a is equal to 6 by 5. A is 6 by 5. Now in the first, we have to find coordinates of the focus. We know here coordinates of the focus for the given parabola is here a 0. Okay, so here we define focus first. Here first point, focus. We know coordinates of the focus are here a 0 and is equivalent to, here we know a is 6 upon 5. So 6 upon 5, 0 are the coordinates of the focus. Then in second, we have to find equation of the directrix. We know here for the given parabola equation is x is equal to minus a, that is x plus a is equal to 0. Okay, so here equation of the directrix is equation of Directrix is here x plus a is equal to 0. Therefore, here x plus, we know a is 6 upon 5. So we replace a by using 6 upon 5 and is equal to 0. And in last, here we get 5x plus 6 is equal to 0. This is the equation of the Directrix. In next, we have to find the length of the lattice rectum. Here for the length, we consider 4a. Okay. So here length of lattice rectum is length of lattice rectum is equal to 4a equal to 4 into, we know a is 6 upon 5 and this is equal to 24 upon 5. Here is 24 upon 5. And in last, here we have to find endpoints of the lattice rectum. Here for the endpoints, we consider a to a and a minus 2a. Okay. So here coordinates are coordinates of endpoints are, we know here endpoints are, here is having a to a and here a minus 2a, a minus 2a. That is, here we get, we know a is 6 upon 5 and 2a means 2 into 6 by 5, that is 12 by 5. And here again a is 6 upon 5, then minus 2a means here minus 12 by 5. Minus 12 by 5. So these are the end points of the lattice rectum. So remember these endpoints. Okay, directly we replace a by using 6 by 5 in that coordinates. Okay, so a very simple example it is. Directly by using our formulae, we find all those points. We find all those points. Let's go with our next example. Here in the next, given 3x square is equal to 8y is equal to 8y. This is the given equation of the parabola. Okay. Now here we consider given equation again. Here is 3x square is equal to 8y. Let's divide both the sides by 3. If we divide, we get x square is equal to 8 by 3y. Now we know this equation is of the form, here x square is equal to 4by. Remember, here this is of the form, x square is equal to 4by. Here we know 4b is equal to 8 by 3. Okay, so here we get b separately and here b is 8 by 12. 8 by 12 means 2 by 3. Here is 2 by 3. Okay, so we get this b. Now using this b, we have to find all those points. Firstly, we have to find the focus. Okay, here for the focus of the given equation of the parabola, here is 0b. Okay, so here focus is equivalent to 0b and is equivalent to here 0. We know b is 2 by 3. So these are the coordinates of the focus. Next, we have to find equation of the directrix. Here we know for the parabola x square is equal to 4by. Equation of directrix is y is equal to minus b. Since y is equal to minus b is given, here we get y plus b is equal to 0. So this is the equation. Equation of the directrix is y plus b is equal to 0. Okay, therefore here y plus, we know b is 2 by 3 is equal to 0. and in last we get 3y plus 2 is equal to 0. This is the required equation of the directrix. In third, we have to find the length of lattice rectum. Here for the length we consider 4b. Okay, so in next, length of lattice rectum is equal to 4b, equal to 4 into 2 by 3, since b is 2 by 3, and in last here we get 8 by 3. Here is 8 by 3, and in last we have to find endpoints of the lattice rectum. Endpoints are, we know endpoints of the lattice rectum are, here are 2b and minus 2b. So remember these endpoints. Firstly, here I write 2b and minus 2b. That is, here we get, here 2b means 2 into 2 by 3, that is 4 by 3, and here 2 by 3 as it is, and for minus 2b it is minus 4 by 3, and b is 2 by 3. So these are the endpoints of the lattice rectum. So very simple example it is. Directly by using these formulae we find all these points. So directly on the parabola we define the focus, we define equation of the directrix, we define the length of lattice rectum, and here endpoints of the lattice rectum. Okay, let's go with our next example. Here in the next given, okay, here in the example given, find the equation of parabola with vertex at the origin axis along x-axis passing through the point here point is given having coordinates 3, 4. Again, very simple example it is. Here in this example we have to find equation of the parabola, and for this given, here our parabola passing through the point 3, 4, and here axis of symmetry is along x-axis, and we know here if axis of symmetry is along x-axis, and here point passing through the parabola passing through the point 3, 4, and vertex is at origin. Here given vertex is at origin, then we consider y square is equal to 4ax. This is our equation of the equation of the parabola. So we have to find this type of equation for the given by using the given condition. Okay, so here equation of the form. Here equation of the form y square is equal to 4ax. Okay, let's denote this as 1, since given point passing through the, or our parabola passing through the given point. Here I write but point 3, 4 lies on the parabola, Here this point satisfies the given equation. Okay, so here we know y is 4. Here we know these coordinates are of the form here xy, we know x is 3, y is 4. So we replace x and y in the given equation. Here we get 4 square is equal to 4a into x. We know x is 3. We know 4 square is 16 and this is equal to 12a. This is equal to 12a. Okay, then here we get here we get a is equal to 16 upon 12 is equal to 4 by 3. A is 4 by 3. Okay, let's replace this value of a in the first equation. So from 1, here I write 1 again. Here in the 1 given y square is equal to 4ax. Okay, here y square is equal to 4 into a. We know a is 4 by 3. 4 by 3. Here x as it is. Therefore, y square is equal to 16 upon 3x. And this is the required equation of the parabola. And this equation is of the form y square is equal to 4ax. Okay, so this is required equation of the parabola. So very simple example it is. Directly by using our form y square is equal to 4ax, we find the equation of the parabola. Let's go with our next example. In next here given, find the length of lattice rectum. Find the length of lattice rectum. Lattice rectum of the parabola. Y square is equal to 4ax passing through the point. Passing through the point 2 minus 6. 2 minus 6. Okay, again very simple example it is. Here directly equation of the parabola y square is equal to 4ax is given, and we know here length of the lattice rectum is what? Here is 4. So our first step is here we have to find value of a first. Value of a. Okay, so I write given equation first. Here given y square is equal to 4ax. Okay, but point 2 minus 6 lies on the given parabola, but point 2 minus 6 lies on the parabola. So this point satisfies the given equation. Here we replace x by using 2 and y by using minus 6. So we get minus 6 square is equal to 4 into a into x. X is 2. We know minus 6 square is 36. So 36 is equal to, we know 4 into 2 is 8. So 8a. Then we get here a. Here a is equal to, here 36 upon 8 is equal to, we get here 9 by 2. We get 9 by 2. This is value of a. Now we know here length of lattice rectum is 4a. Okay, so directly we use this form. Therefore, the length of lattice rectum is equal to 4a is equal to 4 into a is 9 by 2 and is equal to 36 upon 2. 36 upon 2 means here we get 18. Here we get 18 units. This is the length of the lattice rectum. Again, very simple example, it is directly by using our length, that is 4a, we find this length. Now we go with our last example. Here in the last given, find the coordinates of the point on parabola y square is equal to 12x. Also find focal distance. Also find the focal distance. Okay. Here parameter is also given. Let's correct this example. Find the coordinates of the parabola y square is equal to 12x, whose parameter is, here given, whose parameter is given and is 1 upon 3. Also find focal distance. Also find focal distance. Okay. Now here parameter is given. Parameter means t is given. If parameter t is given, then we have to consider the coordinates of the point in the form of t. Okay, so we consider given things first. Given equation of the parabola is y square is equal to 12x. Here everyone knows this is of the form, here y square is equal to 4ax. If we compare these two, here we get 4a is equal to 12. 4a is equal to 12 means a is equal to 3. We get a, and here a is 3. Now here we consider the point P. If P is the point, then coordinates of P are, here P is equivalent to at square and here twice at. Remember this point. And we define this point by using the parameter. Okay, now here we know a is 3. Let's replace a by using 3. We know t, that is parameter. Here parameter is 1 upon 3, and we know 1 upon 3 square is 1 upon 9. Then 2 into a is 3 into parameter is 1 upon 3. This is equal to, here we get 3 upon 9 and here 6 upon 3, and in last we get 1 upon 3 and 2. So this is the point on the parabola. Parabola. Now here we have to find the focal distance. Here focal distance is equal to, here for the parabola y square is equal to 4ax, focal distance is always x1 plus a. We defined this in last lecture. Okay, so focal distance is equal to x1 plus a is equal to, we know x1 is 1 upon 3. Here x1 is from the point P and is 1 upon 3 plus a is what? A is 3 is equal to, we get 1 plus 9 upon 3 and in last we get 10 upon 3. So this is the focal distance. So in today's lecture we consider some important points about the parabola. We define these in this table, and we see some important examples related with these points of the parabola. Thank you.